this video, we'll see class 10 Introduction to Trigonometry chapter, in that elimination of trigonometric ratios. The previous video I did few sums. This video is a continuation of the previous one. Okay, first sum. If cos theta minus sin theta is equal to L, tan theta is equal to m secant squared theta, then prove that L squared plus 2m is equal to 1. Okay, so here LHS is L squared plus 2m. I have to prove that that is equal to 1. So when I am substituting this L squared and 2m. So L squared is cos theta minus sin theta the whole squared plus 2 into, here in this one m value is not given like this. So from this given equation we have to eliminate the m value, then we will substitute it in this given LHS. So here m value we will get it as tan theta by secant squared theta. That is our m value. So that we will substitute it here. Directly m value is not given, but from the given equation we can eliminate m. So when we are eliminating m, we will get tan theta by secant square theta. That I am substituting here. Tan theta by secant square theta. Okay. Now, as usual, cos square theta plus sin square theta minus 2 cos theta sin theta plus, in this one, tan theta, I can write it as sin theta by cos theta. Then secant square theta is 1 by cos square theta. So that I will simplify. So cos square theta plus sin square theta is 1 minus 2 sin theta cos theta, then plus 2 into this cos theta and 1 cos theta will get cancelled. That is sin theta by cos theta into this 1 by cos square theta will become cos square theta by 1. So 1 cos theta and 1 cos theta will get cancelled. So 1 minus 2 sin theta cos theta plus 2 sin theta cos theta. So this and this will get cancelled. We will get the value as 1. That is the RHS value. In sum is, if tan A plus sin A is equal to m and tan A minus sin A is equal to n, then prove that m squared minus n squared the whole squared is equal to 16mn. So in this m squared and n squared is given. So first we will find out that one. So m squared is tan A, we will do it directly, tan squared A plus sin squared A plus 2 tan A sin A. So this is our m squared. Then n squared is tan squared A, it is tan A minus sin A. So tan squared A plus sin squared A minus 2 tan A sin A. So this I will substitute it in LHS. So LHS is m squared minus n squared the whole square. So when I substitute this, m squared value is tan squared A plus sin squared A minus, plus 2 tan A sin A. Then minus n squared. So I will multiply all these three terms with minus. So minus tan squared A minus sin squared A plus, here minus is there, so it will become plus 2 tan A sin A the whole square. This is only given in the question. So everything will get cancelled. Plus tan A minus tan A plus sin A minus sin A will get cancelled. So balance I will get it 4 tan A into sin A the whole square. So this is equal to 16 tan squared A into sin squared A. This is my LHS. Okay. Then RHS is 16 MN. So that we will do it separately. So I will write the LHS value here. LHS, I got it as 16 tan squared A sin squared A. This is my LHS. Then RHS is 16 MN. So 16 is there. M value is tan A plus sin A. N value is tan A minus sin A. So this one is in the form A plus B into A minus B. So 16 tan squared A squared minus B squared. Okay, so this 16 tan squared A, I can write it as sin squared A by cos squared A minus sin squared A. So the sin squared is common in both the terms. So I am taking it outside. Okay, then when I take LCM, cos squared A will be there, and then 1. If I take sin squared A out, balance is 1 by cos squared A minus 1. So I will get 1 minus cos squared A. Understood? So again this cos squared A, I am bringing it here. So I will get, so 16 sin squared A, this cos squared A, I am bringing it out. So cos squared A, I will write it below this. So balance will be 1 minus cos squared A. So that is sin squared A. So this is 16 sin squared A by cos squared A is tan squared A. So 16 tan squared A sin squared A. So this is my LHS. So LHS is 16 tan squared A sin squared A, and my RHS value is also 16 tan squared A and sin squared A. So I have proved this sum. Third sum. If cos A by cos B is equal to M and cos A by sin B is equal to N, show that M squared plus N squared into cos squared B is equal to N squared. Okay, so here M squared. So LHS is M squared plus N squared into cos squared B. So M squared is cos squared A by cos squared B plus N squared is cos squared A by sin squared B into cos squared B. Then when I take LCM, cos squared B, sin squared B, the numerator I will get cos squared A into sin squared B plus cos squared A into cos squared B. This is inside the bracket. Outside I have cos squared B. So now cos squared A sin squared B plus cos squared A cos squared B is there. In this I will take cos squared A outside. Balance will be sin squared B plus cos squared B by cos squared B into sin squared B into cos squared B. So here cos squared B and here cos squared B will get cancelled. So in the here we have, so sin squared B plus cos squared B is 1. So remaining is cos squared A into 1 by the denominator I have only sin squared B. So this one cos A by sin B the whole square. So cos A by sin B is nothing but n squared. But here is equal to n squared. So this only I have asked to prove. So this is my RHS. Fourth sum. If cosecant theta minus sin theta is equal to m and secant theta minus cos theta is equal to n, prove that m squared n whole power 2 by 3 plus n squared whole power 2 by 3 is equal to 1. So this one, first we will find the value of m squared n whole power 2 by 3 separately. We will find the value for these two things separately, then we can add it. So m squared n whole power 2 by 3. So m squared. So m squared is cosecant theta minus sin theta. This is m whole squared into n. So into n is secant theta minus cos theta. This one is whole power 2 by 3. Whole power 2 by 3. So this one cosecant is 1 by sin theta minus sin theta the whole squared into the secant is 1 by cos theta minus cos theta whole power 2 by 3. So when I simplify this, sin theta I will get whole squared. Sin theta is the denominator and here in the numerator I will get 1 minus sin squared theta. So when I find the LCM I will get 1 minus sin squared theta. Same way here also. Cos theta is the denominator and in the numerator I will get 1 minus cos squared theta whole power 2 by 3. Okay. So 1 minus sin squared theta is cos squared theta. One square is there outside. So I will get cos power 4 theta in the numerator. Cos power 4 theta. Okay. Then denominator is sin squared theta. This square I am multiplying inside. 1 minus sin squared theta is cos squared theta. So cos squared theta the whole squared will be cos power 4 theta into 1 minus cos squared theta is sin squared theta by denominator is cos theta. This whole power 2 by 3. Okay, then the sin squared theta and sin squared theta will get cancelled and cos theta here 1 cos theta is there, here 4 cos power 1 theta is there, here cos power 4 theta is there. So when I simplify this I will get cos cube theta. So I will get cos cube theta whole power 2 by 3 I will get. So this one will be cos theta whole power 3 into 2 by 3. So this 3 will get cancelled. We get cos squared theta. This is only for this part. So for one part we got the answer as cos squared theta. So I will write that here. Cos squared theta is answer for that part. Then same procedure you have to follow for the other one also. Mn squared whole power 2 by 3. The same thing. So m value is cosecant theta minus sin theta. This is m and n squared is there. So secant theta minus cos theta the whole square. So this whole power 2 by 3. Okay. For that it is given 2 by 3. So the same procedure 1 by sin theta minus sin theta for this part and here 1 by cos theta minus cos theta the whole squared whole power 2 by 3. So this one will be 1 minus sin squared theta by sin theta into 1 minus cos squared theta by cos theta whole square whole power 2 by 3. So 1 minus cos squared theta, sin squared theta is cos squared theta by sin theta into 1 minus cos squared theta is sin squared theta, the whole square. So it will be sin power 4 theta by cos theta, the whole square is cos squared theta, the whole power 2 by 3. Okay, so cos squared theta and cos squared theta will get cancelled. Same way sin theta, and here 4 sin power 4 theta is there. So one sin is there, so that we will cancel. We'll get sin cube theta. So sin cube theta whole power 2 by 3. When you simplify, you will get sin square theta. So when you simplify this part, you will be getting cos square theta. And when you simplify this, you will be getting sin square theta. So when you add that sin square theta plus cos square theta, it is 1. That is the first identity. So LHS is, when you simplify this, that is m squared n whole power 2 by 3 and n squared whole power 2 by 3. When you are simplifying this, you will get, when you are substituting the values for m and n, after simplification you got cos square theta here, and here you got sin square theta. So we know that sin square theta plus cos square theta identity is 1. So that is our RHS value. So you got the value for this. Fifth sum. If x is equal to r sin alpha cos beta and y is equal to r sin alpha sin beta, z is equal to r cos alpha, prove that x squared plus y squared plus z squared is equal to r squared. So LHS is x squared plus y squared plus z squared. So x squared is r squared sin squared alpha cos squared beta plus y squared is r squared sin squared alpha sin squared beta. Then z squared is r squared cos squared alpha. So in this one, when you take these first two terms, r squared sin squared alpha and r squared sin squared alpha is common. So I take that one outside, r squared sin squared alpha. So balance I have cos squared beta plus sin squared beta. So the remaining, the last one, I'll keep it as it is. Okay, so this one is cos squared beta plus sin squared beta is 1. So r squared sin squared alpha plus r squared cos squared alpha. That is the balance we have. This value is 1. So you will get r squared sin squared alpha into 1 is r squared sin squared alpha plus r squared cos squared alpha. So in this r squared, if I take common out, balance will be sin squared alpha plus cos squared alpha. So that is r squared. This value is 1. So this is my RHS. So with this 5 sums, I have completed introduction to trigonometry topic. All the sums I have covered. I have completed class 9 number system first chapter I have completed, and in class 10 introduction to trigonometry chapter I have completed. If you have any queries, any doubts, you can post it in the comment box. Thank you.